And then when we talk about when we talk about interventions, it's important that we understand about energy monitoring and the role that refrigeration systems can play in that. So energy monitoring and refrigeration systems would involve tracking and analyzing energy consumption to optimize performance, reduce costs, and improve efficiency. And by measuring real-time energy use, the refrigeration systems can be adjusted to minimize waste, avoid unnecessary energy consumption, and maintain optimal operating conditions. Now, there's some key components of this. The first, of course, are the energy meters. Now, these are simple devices that measure and record electrical consumption, providing data on the power usage of refrigeration units or maybe for entire facilities, looking at the voltage and the current and the power factor, and being able to provide real-time insights into energy consumption patterns, helping operators to identify inefficiencies and any anomalies. So their common use might be for maybe down to compressors or refrigerated cabinets or cold rooms, often installed in a panel, maybe locally to the data manager, maybe not, they might be spread across a large facility. But it's important that you extract that information from those energy meters so that you know what's going on across the site. If there's any potential increases in energy consumption on a particular asset, it might be that there's an underlying maintenance issue so that you can make those proactive decisions. And it's important that you can have access to energy dashboards. And these are basically visual tools that can consolidate all of that energy data from various sources, such as energy meters, sensors, into a central dashboard. And it might not just be energy meters, they could be pulse meters for water consumption and gas. And these dashboards will provide real-time insights and historical data, helping operators track energy performance, set energy saving targets, and monitor trends. They would often include alerts, reporting features, notifying operators of energy anomalies or inefficiencies. And this is really important because you need to know what's going on in real time. Are there any underlying issues that need to be addressed very quickly? So they could be installed in control panels as part of the BMS system. They'd often be used by facilities managers or energy managers, and indeed refrigeration engineers, to monitor the overall energy consumption of a refrigeration system. And there's many benefits to monitoring the energy. It helps to optimize the system consumption, identifying areas of waste and inefficiency, and enabling those adjustments to reduce energy usage. And of course, cost. By tracking energy use, organizations can minimize operational costs and avoid expensive energy bills. And of course, operational insights. So it provides detailed data and trends, allowing operators to make informed decisions regarding system performance and maintenance schedules, and regulatory compliance, supporting compliance with energy regulations such as BREEAM, sustainability goals, by basically providing transparency and reporting capabilities. It might be that there's a legacy refrigeration system that's being replaced. You want to be able to compare the relative performance of the new system against the consumption on the old one. By monitoring energy performance, any potential system issues, such as faulty compressors or overuse of energy, can be quickly identified and addressed. And any energy saving strategies that can be enabled through monitoring demand response, adjusting system settings in real time to match energy demand, potentially reducing energy costs during peak periods, load shedding, reducing non-essential energy consumption during high periods, energy optimization, looking at fine-tuning a system's parameters such as compressor speed, defrost cycles, to minimize energy consumption, of course, without compromising on the performance of the system as well. So I think, to conclude, energy monitoring in refrigeration systems is essential for improving efficiency, for reducing costs, and of course meeting sustainability targets. So with tools, energy meters, dashboards, etc., operators can make those real-time adjustments, track energy patterns, and ensure that systems are operating basically as they should be. So let's look at energy reduction. Now, you may have obtained all of that energy data across a system or across a facility or across a whole estate. But what's energy reduction in a refrigeration system? So energy reduction is slightly different, and it focuses on minimizing the energy consumption. You've got access to the data. It's then using that data to make the correct interventions. So through advanced control strategies, energy efficient technologies and real-time monitoring, systems can operate at their best, reducing energy consumption and improving sustainability. So it could be things like optimized compressor control, adjusting compressor speed and operation based on demand, implementing techniques like variable speed drives. It could be looking at efficient defrost controls, such as using defrost algorithms to optimize defrost cycles, demand-based defrosting. Now, of course, there's benefits here in that you could reduce energy consumption by preventing excess energy consumption for prolonged defrost cycles, helping to maintain overall efficiency of the system by minimizing energy loss during defrost operations. It could be making sure that you've got energy efficient fan control. So obviously a refrigeration system has many fans, and it's important that you look at controlling those fan speeds accurately to reduce energy use, perhaps by adjusting based on environmental conditions like external temperatures or room temperatures, implementing variable speed control to maintain optimal airflow. And again, from an energy saving perspective, this can reduce unnecessary fan usage and, of course, reducing wear and tear. Another aspect to consider is integrated system optimization. So coordinating operation across all of the components, your compressors, your fans, your evaporators, your defrost cycles, making sure that they're all working together in synergy with one another, ultimately to reduce consumption. And that's really important in that if you're using data to make those interventions, that they deliver more energy efficiency from that system by avoiding overcooling, excess operation, wear and tear on the system. It might be things like energy monitoring and real-time analytics, as we discussed, constantly monitoring energy performance across a system, allowing for immediate adjustments. It could be advanced control systems, taking intelligent controllers to optimize the performance of a system. And of course, there's many benefits here, not only cost saving through reduced energy costs, but helping to support sustainability efforts by lowering carbon emissions, improve system efficiency, regulatory compliance. And I think to conclude, it's really important, this energy piece around reduction through using an intelligent control system in the refrigeration world. And it's crucial for reducing operational cost, supporting sustainability goals, and through techniques such as optimized compressor control, efficient defrosting, real-time energy monitoring, energy savings can be maximized without sacrificing the actual system performance. Now let's look at PLC. Now PLC solutions are referred to as programmable logic controllers. Now you can have what we'd call a parametric off-the-shelf controller that might meet all of the needs of a project, but sometimes you might need a bespoke control strategy. Now, in a refrigeration control system, it's important that you have the ability to enable automation and precise management of refrigeration processes. So the PLCs can serve as the brain of the system, controlling a wide range of components, maybe the compressors, the fans, the valves, based on input data such as temperature, pressure, humidity. Now, these solutions provide flexibility, scalability, and the ability to integrate with existing systems. Now, these PLCs can be programmed to execute specific control strategies. It might be for pumped glycol for underfloor heating or for evaporator defrosts. And it's important to understand that it provides operators with precise control over refrigeration systems. Again, scalability. You can build your own PLC solutions, which can offer long-term flexibility, accommodating system changes and expansions without requiring a complete overhaul. They allow for continuous real-time monitoring. They can manage the energy by controlling the rotation of all the systems. And this can be carried out through very advanced algorithms. But ultimately, I think the main benefits of a PLC system is that they're completely customizable. So they're tailored solutions to ensure that optimal performance and energy efficiency, regardless of system size or complexity. They're scalable, so it's easy to adapt to a changing system need, making it suitable for small and large installations. And of course, the reliability, providing real-time control and monitoring, ensuring optimal operation and reducing the risk of equipment failure. So to conclude, a PLC solution essentially offers advanced control and monitoring capabilities for refrigeration systems, providing flexible, scalable, and efficient management of complex refrigeration processes. With real-time control, energy optimization, and remote monitoring, the PLCs help improve the system performance, they help reduce costs, and they ensure reliability, making them essential for modern refrigeration operations.